In the vast and often horrifying tapestry of human conflict, certain machines emerge that seem to transcend the boundaries of mere engineering. They are feats of design so audacious, so monstrous in their conception, that they appear to have been ripped from the annals of ancient mythology or a dystopian future. Among these awe-inspiring yet terrifying creations stands a true titan, Schwerer Gustav. This leviathan of steel and fire was unlike anything the world had ever witnessed, a weapon that redefined the very meaning of heavy artillery. Imagine, if you will, a gun stretching nearly 50 meters, 164 feet, in length, its colossal barrel alone measuring over 32 meters, 105 feet. Envision a behemoth weighing in excess of 1,350 metric tons, a mass equivalent to more than 20 of the largest blue whales combined. This is not a fanciful relic from a forgotten age of giants, nor a fantastical construct from the darkest corners of science fiction. This is the chilling, tangible reality of Schwerer Gustav, the heaviest and largest caliber rifled weapon ever to unleash its fury in the crucible of combat. Its very name, Heavy Gustav, almost comically understated the awesome, earth-shattering destructive power it commanded. This was a beast meticulously engineered to obliterate the seemingly unbreakable, to tear through fortifications deemed impenetrable, and to instill a primal, paralyzing fear in the hearts of those who dared to face its monstrous projectiles. But how did such an impossible machine come to exist? What desperate strategic imperative spurred its creation? What incredible, almost insurmountable logistical and engineering challenges had to be overcome to bring this behemoth to the battlefield? What unimaginable devastation did it unleash upon its targets? And what ultimately became of this ultimate yet fleeting expression of industrial might? Prepare to embark on an unparalleled journey into the definitive history of the largest gun ever to fire in anger. A story that pushes the boundaries of human ingenuity, strategic ambition, and the brutal realities of total war. Before we delve deeper into the colossal narrative of this engineering marvel, if you are captivated by the untold stories of human ingenuity, the dramatic sagas of conflict, and the incredible machines that shaped history, then please take a moment to press that subscribe button below. Your support is instrumental in helping us uncover and share more compelling and meticulously researched historical accounts like this one. Thank you for being a vital part of our growing community. Now, let us return to the monumental tale of Schwerer Gustav. The genesis of Schwerer Gustav can be meticulously traced back to the volatile and increasingly aggressive political climate of the 1930s. This was a period characterized by fervent rearmament and ambitious strategic planning within Germany. Following the devastating conclusion of the First World War, the Treaty of Versailles had imposed severe restrictions on Germany's military capabilities. However, with Adolf Hitler's ascent to power in 1933, these restrictions were systematically and ruthlessly dismantled. Hitler envisioned a resurgent and dominant Germany, poised to conquer Europe, and this vision necessitated a military capable of overcoming any conceivable obstacle. One of the primary strategic concerns for Germany in the West was the formidable French Maginot Line. Conceived in the grim aftermath of the devastating trench warfare of World War I, the Maginot Line was far more than a mere series of bunkers. It was a vast, intricately interconnected defensive system, stretching for hundreds of kilometers along France's eastern border with Germany and Italy. It comprised multiple layered defenses, formidable anti-tank obstacles, dense barbed wire fields, meticulously prepared infantry positions, and most notably, deeply entrenched casemates and massive ouvrages, or fortresses. These ouvrages were, in essence, self-contained underground cities, boasting concrete walls up to 3.5 meters, 11.5 feet, thick, armored turrets, a full complement of anti-tank guns, machine guns, artillery pieces, and even underground railways for efficiently moving supplies and personnel. Designed to be impervious to all but the most sustained and heavy bombardment, the Maginot Line was widely considered the epitome of defensive engineering, an impregnable barrier against which any frontal assault would inevitably be suicidal. Germany, in turn, began the construction of its own defensive line, the Siegfried Line, also known as the West Wall, facing the Maginot. While generally less technologically advanced than its French counterpart, the Siegfried Line was still a substantial barrier. Hitler recognized that if Germany were ever to launch an offensive against France, merely bypassing the Maginot Line might not be sufficient. He required an absolute means to directly neutralize its most powerful fortifications if such a necessity arose. It was within this charged context, in 1934, that Adolf Hitler, during a fateful visit to the Rheinmetall-Borsig artillery works, laid down an audacious and seemingly impossible challenge to the leading German arms manufacturers. He demanded the creation of a super-heavy gun, an entirely new class of weapon, uniquely capable of utterly destroying the most robust fortifications of the Maginot Line. Specifically, he requested a gun that could fire a projectile weighing at least 7 metric tons, 7,000 kilograms, 15,400 pounds, and achieve a penetration of 1 full meter, 3.3 feet, of solid steel armor, or, alternatively, a staggering 7 meters, 23 feet, of reinforced concrete. And crucially, it had to accomplish this destructive feat from a range that would keep the gun safely beyond the reach of the heaviest French counter-battery fire. This was not an incremental improvement upon existing artillery. It was a demand for a weapon that seemed to defy the known limits of physics and engineering. The monumental task of bringing this vision to life fell to the venerable Krupp Arms Works of Essen, Germany. The Krupp family boasted a centuries-old legacy, dating back to the 16th century, of unparalleled metallurgical innovation and arms manufacturing, proudly serving Prussian kings and German emperors with a succession of increasingly powerful and innovative cannons. Gustav Krupp von Bohlen und Halbach, the patriarch of the Krupp industrial empire at the time, entrusted his most brilliant engineers, led by the visionary Dr. Erich Miller, with this seemingly impossible design brief. The initial design phase, spanning from 1934 to 1937, was a period of intense theoretical work, meticulous material science exploration, and countless calculations. Dr. Emmentaler's team faced unprecedented challenges. How does one contain the immense pressures generated by the colossal propellant charge required to launch a 7-ton projectile? How could the barrel possibly withstand the unimaginable wear and tear of such colossal forces? Not just once, but repeatedly. What kind of recoil system could effectively absorb the truly staggering energy generated with each firing? And perhaps most fundamentally, how could such an enormous and intrinsically heavy structure be effectively transported and precisely aimed on a battlefield? The engineers explored various calibers, ranging from an 800 millimeter, 31.5-inch option to even larger 1,000mm 39.4-inch designs. Ultimately, the 800mm caliber was chosen as the most feasible, a term that barely applied to a weapon of this colossal scale, given its still monumental engineering challenges. This meant the internal diameter of the gun's barrel would be 80 centimeters, over 2.5 feet wide, large enough, astonishingly, for a person to crawl inside. With the designs meticulously approved, construction officially commenced in 1937 at Krupp's vast manufacturing complex in Essen. The sheer scale of the fabrication was staggering. The gun could not, under any circumstances, be built as a single, contiguous unit. Instead, it was meticulously manufactured in numerous gargantuan components, each requiring highly specialized machinery and bespoke techniques. The main barrel, a hollow steel cylinder more than 32 meters, 105 feet in length, was a masterpiece of heavy industry, requiring enormous forging presses and unparalleled precision machining to achieve its perfectly smooth and accurate bore. The breech mechanism, a complex system designed to withstand and hermetically seal against the explosive forces of detonation, was equally massive and intricately engineered. Every structural beam, every gear, every hydraulic component of the gun's immense railway carriage was a custom-made engineering marvel, fashioned from tons of high-grade steel. Thousands of skilled metallurgists, welders, machinists, and engineers toiled for years, relentlessly pushing the boundaries of material science and manufacturing processes to bring this metallic leviathan to life. The construction cost was enormous, equivalent to hundreds of millions of modern dollars, and its production consumed vast quantities of Germany's precious strategic raw materials and highly skilled labor. The first 800mm gun was finally completed and declared ready for its initial firing trials in 1941. It was officially named Schwerer Gustav, or Heavy Gustav, a direct and fitting homage to Gustav Krupp, whose family had so profoundly shaped German industrial and military power for centuries. A second, almost identical gun, initially intended to be a backup or a twin, was also produced and named Dora, reportedly after Dr. M. Ahler's wife, though Dora's operational history would ultimately prove to be even more limited than Gustav's. The firing trials themselves were conducted under the utmost secrecy and involved immense logistical preparations, confirming the gun's unprecedented destructive potential even if its practical application remained a monumental challenge. By the time Schwerer Gustav was finally ready for active deployment, the geopolitical landscape of World War II had shifted dramatically and unexpectedly. The weapon's original intended target, the formidable French Maginot Line, had been rendered strategically irrelevant. In the lightning-fast spring offensive of 1940, the German Wehrmacht had executed a brilliant flanking maneuver, pushing through the Ardennes forest and entirely bypassing the Maginot Line, leading to the rapid and shocking fall of France. Gustav, the ultimate fortress buster, now found itself a weapon without its intended primary target, an anachronism almost before its first shot. However, a new and even more brutal theater of operations soon emerged with Operation Barbarossa, the German invasion of the Soviet Union, launched in June 1941. While the initial German advance was stunningly rapid and successful, the Wehrmacht soon encountered fierce, almost fanatical, Soviet resistance, and some of the most formidable defensive fortifications ever constructed. Among these, the Crimean Peninsula, and particularly the strategically vital port city of Sevastopol, became a crucial and brutally contested objective. Sevastopol, vital as the main base for the Soviet Black Sea Fleet, was considered one of the most heavily fortified positions on Earth. Its defenses were the product of decades of meticulous Soviet engineering, designed to withstand prolonged siege and sustained naval bombardment. The city was protected by concentric rings of concrete fortifications, some referred to as Stalin Line bunkers, intricate underground tunnel networks, hidden artillery positions, and deeply entrenched troop emplacements. Prominent among these were massive coastal artillery batteries, such as Maxim Gorky I and Maxim Gorky II, which featured colossal naval guns protected by reinforced concrete walls up to 4 meters, 13 feet, thick. Other critical strongpoints included the White Cliff and the Northern Fort, each a veritable bastion of concrete and steel. Most critically, deep beneath Sevastopol Bay, carved into more than 30 meters, 100 feet of solid rock and reinforced concrete, lay a vast underground ammunition depot, considered utterly impervious to any conventional weapon. The German 11th Army, under Field Marshal Erich von Manstein, knew that a direct assault on these positions would be catastrophically costly. They needed something truly extraordinary to break this deadlock. They needed Schwerer Gustav. The task of transporting Gustav to the Crimean front was an engineering and logistical nightmare of unprecedented proportions, an entire military operation in its own right. The gun, weighing its immense 1,350 tons, could not be moved on any standard railway. It had to be completely disassembled into hundreds of individual components, with the heaviest pieces weighing up to 250 tons, 550,000 pounds each. These gargantuan components were then loaded onto 25 specialized railway cars. The entire convoy, when fully assembled for transport, stretched for an astonishing 2.4 kilometers, 1.5 miles, and required an array of multiple powerful locomotives to pull it along the tracks. The journey from Germany to Crimea was slow, arduous, and constantly threatened by partisan attacks and aerial reconnaissance. Upon reaching the staging area near Sevastopol, the logistical challenges only intensified. Gustav could not simply be rolled onto existing tracks and fired. It required a specially constructed, dedicated double-track railway siding to support its immense weight and accommodate its enormous width. This construction was itself a massive military operation, requiring dedicated railway construction battalions to lay down new track, sometimes hundreds of meters long, often under the constant threat of Soviet artillery fire and aerial attacks. The double track was absolutely essential to distribute the gun's colossal weight and to provide the necessary stability for firing. Preparing the firing site alone took weeks of arduous, round-the-clock labor, involving thousands of workers, engineers, and soldiers. The operational crew for Schwerer Gustav was a small army unto itself, numbering approximately 2,500 men. This included a commanding officer, a dedicated technical staff of highly specialized engineers and ballistic experts, a large contingent of construction troops for ongoing track maintenance and site preparation, security personnel to guard the invaluable asset against sabotage, and a substantial anti-aircraft unit. This anti-aircraft defense, equipped with numerous light and heavy flak guns including multiple 88mm anti-aircraft guns, was absolutely crucial, as Gustav's immense size and stationary nature made it an obvious and high-priority target for Soviet bombers. The daily routines of this massive crew involved constant maintenance, logistical coordination, and vigilance. Housing, feeding, and supplying these 2,500 men in a war zone added another layer of complexity to an already gargantuan undertaking. Assembling Gustav at the firing site was an intricate ballet of heavy machinery and human coordination that could take up to 6 weeks. 2 massive gantry cranes, themselves transported in pieces and assembled on site, were required to lift and precisely position the heaviest components, such as the colossal 32-meter, 105-foot barrel, and the immense breech mechanism, onto the specially designed railway carriage. The precision required for aligning these multi-ton components was extraordinary, as even slight misalignments could compromise the gun's structural integrity or firing accuracy. Once assembled, the gun stood over 47 meters, 155 feet, long, and 12 meters, 40 feet high. A truly terrifying and awe-inspiring silhouette against the Crimean sky. Finally, by late May 1942, Schwerer Gustav was positioned on its firing platform high above Sevastopol, its colossal barrel aimed at the formidable Soviet defenses. Its specifications were staggering, almost mythical. Caliber, 800 millimeters, approximately 31.5 inches, making it the largest caliber rifle gun ever used in combat. Overall length, 47.3 meters, 155 feet. Total weight, 350 tons, 2,976,300 pounds. Barrel length, 32.5 meters, 106 feet. Effective range, up to 39 kilometers, 24 miles, for its standard high-explosive shells, and an astonishing 47 kilometers, 29 miles, for lighter experimental projectiles. Rate of fire, incredibly slow, averaging only about 14 rounds per day, or roughly 1 round every 1 hour and 40 minutes, primarily due to the lengthy and extremely laborious reloading process. Gustav primarily fired 2 types of shells, each a monster in its own right. High-explosive shells, ATHE, weighing approximately 4,800 kilograms, 10,600 pounds, these shells carried a massive explosive charge. Upon impact, they created immense craters over 10 meters, 33 feet deep and wide, obliterating everything within a considerable radius and causing catastrophic concussive damage. Armor-piercing shells, AP, even heavier, at 7,100 kilograms, 15,700 pounds, these projectiles were specifically designed to penetrate the thickest concrete and steel. They featured a hardened steel cap, designed to pierce multiple layers of defense before detonating deep within the target. The firing sequence was a truly awe-inspiring spectacle of raw power. After the painstaking process of loading the shell, which involved a specialized gantry crane mounted on the gun itself and a large crew working in unison, the gun would be meticulously aimed. Elevation and traverse were achieved through powerful electric motors and gears. Then, with a series of commands and safety checks, the propellant charges would ignite, unleashing an explosive force almost beyond comprehension. The ground would shake violently. A massive fireball hundreds of feet across would erupt from the muzzle, followed by a deafening, visceral roar that could be heard for tens of miles. The immense recoil would physically push the entire 2,976,000-pound gun carriage back several meters along its special tracks, before the powerful hydraulic recoil system slowly, ponderously, brought it back into firing position. Between June 5th and July 4th, 1942, Schwerer Gustav unleashed its fury upon Sevastopol. Over this relentless month, it fired a total of 48 colossal rounds, each one a precision strike aimed at the most hardened Soviet defenses. Its impact on the siege was undeniable, both in terms of material destruction and profound psychological effect. One of its most legendary accomplishments was the complete destruction of the aforementioned underground ammunition depot located deep beneath Sevastopol Bay. Despite being protected by over 30 meters, 100 feet, of reinforced concrete and natural rock, Gustav's armor-piercing shells, precisely aimed and designed for extreme penetration, punched through these incredible layers of earth and concrete. The subsequent detonation of the vast magazine caused a catastrophic explosion, sending a colossal plume of smoke, dust, and debris hundreds of feet into the air, a truly unique feat of destruction that no other weapon of the era could have achieved. This single event demonstrated Gustav's unparalleled capability to neutralize targets that were utterly impervious to all other forms of attack, including sustained aerial bombardment and naval gunfire. Other critical targets included the heavily armored coastal batteries. For example, the Fort Maxim Gorky III, a formidable dual-turreted battery with 13-foot-thick walls, was heavily damaged by Gustav's projectiles. The direct hits disrupted its aiming mechanisms, fractured its concrete superstructure, and effectively silenced its massive naval guns, significantly reducing its effectiveness. The northern fort, another crucial defensive position guarding the approaches to the city, also sustained crippling direct hits that caused severe structural damage and eliminated its operational capacity. Even targets that were not directly penetrated suffered immense concussive damage, with concrete shattering, machinery being dislodged, and crews being disoriented by the sheer overwhelming force of the explosions. Buildings within Sevastopol, used as command posts or strong points, such as the Stalin Fortress, were reportedly obliterated with single direct hits, turning them into rubble. The psychological impact on the Soviet defenders was profound. They knew that no bunker, no matter how deep or how thick, was truly safe from this monstrous German weapon. The unique sound of its firing, the earth-shattering impact of its shells, and the horrifying sight of its destructive power created a pervasive and inescapable sense of dread. Despite its undeniable destructive capability and its undeniable successes at Sevastopol, Schwerer Gustav was far from a perfect weapon. Its colossal size, while enabling its devastating firepower, was simultaneously its greatest weakness, rendering it a logistical nightmare and an almost untenable strategic liability. Immense vulnerability. Its sheer size and its static, railway-bound nature made it an extremely vulnerable target for aerial attack. The vast anti-aircraft screen required to protect it, involving hundreds of flak guns and thousands of personnel, diverted significant, scarce resources from other critical areas of the German war effort. Any breakdown, mechanical failure, or logistical hiccup could leave it exposed for days or weeks. Crippling logistical burden. The logistical demands were simply staggering. The continuous supply chain for the hundreds of specialized railcars for components and ammunition, the thousands of dedicated personnel, the weeks of arduous assembly and disassembly, and the constant maintenance drained immense resources, materials, manpower, fuel, and transport capacity that could have been allocated to more versatile and effective weapon systems. The daily consumption of fuel and supplies for the support crew alone was enormous, comparable to supplying a small army division. Extremely slow rate of fire. With a rate of fire averaging only about 14 rounds per day, Gustav could not provide sustained fire support or respond quickly to dynamic, fast-moving battlefield conditions. It was a strategic asset, designed for a very specific, static siege scenario, not a flexible tactical weapon. Its deployment and redeployment consumed so much time that it was often strategically obsolete by the time it was ready to fire again. Rapid barrel wear. The immense pressures and temperatures generated by firing the gargantuan shells caused rapid and severe wear to the barrel's rifling. After the 48-liter Artillerie 48 rounds fired at Sevastopol, the original barrel was effectively worn out and had reached the very end of its projected operational lifespan. While Krupp had ingeniously provided a spare barrel itself, an engineering marvel and logistical challenge to transport, replacing it was another multi-day, highly complex operation, requiring the same massive cranes and specialized crews as the initial assembly. Each barrel had an estimated lifespan of only about 300 rounds, a very limited operational life for such an incredibly costly and difficult-to-produce component. The barrel replacement effectively rendered the gun inoperable for a significant period, demanding a major logistical effort for its exchange. After the successful but incredibly costly siege of Sevastopol in July 1942, Schwerer Gustav was meticulously dismantled and transported back to Germany for extensive refurbishment, maintenance, and the crucial replacement of its worn-out barrel. During this period, there were discussions and ambitious plans for its potential deployment to other major siege operations on the Eastern Front, most notably against the heavily fortified Soviet city of Leningrad. However, the sheer logistical difficulties associated with transporting and deploying Gustav to the northern Russian front, combined with the rapidly deteriorating strategic situation for Germany and the increasing scarcity of vital resources, ultimately rendered its deployment there impractical. The Red Army's defenses around Leningrad were also incredibly dense, and German strategic priorities shifted dramatically towards more mobile warfare. In 1944, as the German war effort grew increasingly desperate, and the fronts began to collapse, there were even fleeting plans considered for deploying Schwerer Gustav to suppress the brutal Warsaw Uprising in Poland. However, by this point, the strategic realities had fundamentally changed. Allied air superiority over Europe was almost absolute, making the transport and operation of such a massive, slow-moving, and inherently vulnerable target an almost suicidal undertaking. The necessary resources, particularly the thousands of troops, dedicated anti-aircraft defenses, and critical railway capacity, simply could not be spared from the collapsing front lines. The days of uncontested German logistical operations were long over. As the Soviet Red Army advanced relentlessly deeper into German territory in early 1945, closing in on the very heart of the Third Reich, the fate of Schwerer Gustav became a critical concern for the German High Command. They could not, under any circumstances, allow such a potent and technologically advanced symbol of German engineering prowess to fall into enemy hands. The propaganda value for the Allies, particularly the Soviets, of capturing the world's largest gun intact would have been immense. Therefore, in a final grim act of strategic denial, just weeks before the ultimate inevitable collapse of Nazi Germany, on April 14, 1945, near the small Bavarian town of WWII, the Schwerer Gustav was deliberately destroyed by its own retreating crew. Explosives were carefully placed and detonated, shattering the colossal gun barrel, its intricate breech, and its immense railway carriage into thousands of twisted, unrecognizable pieces of scrap metal. It was a violent, self-inflicted end to a weapon built for unprecedented destruction, ensuring that the giant would never fire a shot for the enemy. Advancing American troops discovered the mangled, pathetic wreckage of Schwerer Gustav shortly thereafter. What they found was not a majestic weapon of war, but a contorted, twisted hulk, a desolate testament to its own immense power turned inward. The Soviets later salvaged parts of the wreckage, though its ultimate fate remains somewhat uncertain, most likely melted down for raw materials after exhaustive study. The second gun, Dora, met a similar ignominious end, reportedly being blown up by its German crew near Chemnitz in Saxony to prevent its capture by the Red Army, leaving behind another scene of monumental destruction. Schwerer Gustav stands as a truly unique, almost bizarre and undeniably awe-inspiring chapter in the annals of military history. It was a weapon born of audacious ambition and incredible engineering skill, relentlessly pushing the absolute limits of what was technologically possible at the time. It fulfilled its primary mission at Sevastopol with devastating, indeed unique, effectiveness, demonstrating a penetration capability unmatched by any other artillery piece before or since. Yet, its inherent impracticality, its crippling logistical demands, its immense vulnerability to air power, and its incredibly slow rate of fire ultimately consigned it to a role of very limited strategic utility. It represented a philosophy of warfare that was rapidly becoming obsolete. The reliance on overwhelming static firepower to crack fixed, impenetrable defenses. The future of warfare lay in mobility, flexibility, combined arms tactics, and the overwhelming power of air superiority qualities that Schwerer Gustav utterly lacked. The colossal resources poured into its design, manufacture, transport, and operation were immense, representing a staggering investment of Germany's most precious steel, manpower, and industrial capacity. Historians continue to debate whether this immense expenditure was truly justified by its single, albeit significant, operational success, or whether it represented a strategic folly, an opportunity cost that deprived other, more versatile weapons programs of vital resources, despite its ultimate obsolescence and its very limited operational career. Schwerer Gustav remains an enduring symbol. It is a monument to the extraordinary human capacity for engineering marvels, to the relentless and at times frightening pursuit of technological advantage, and to the often unforeseen realities and unavoidable limitations imposed by the brutal crucible of the battlefield. It was a titan of steel, a beast that moved on rails, a weapon that fired shells the size of small cars, a true one-of-a-kind. Its story is a powerful illustration of the incredible destructive potential unleashed by human ingenuity, and a stark reminder that sometimes the biggest, most powerful gun isn't always the most effective or efficient solution. Its legacy is not just one of destruction, but also one of unparalleled ambition and a chilling testament to the extremes of wartime engineering, forever etched into the history books as the most massive artillery piece ever to roar onto the battlefield. And that concludes our incredibly detailed look at Schwerer Gustav. What are your final thoughts on this colossal cannon? Do you believe its engineering brilliance justified its immense logistical footprint and limited use? Or was it a magnificent anachronism? We'd love to hear your insights and opinions in the comments section below. If you found this deep dive into military history and extreme engineering fascinating and informative, please give this video a thumbs up, and most importantly, hit that subscribe button to join our community. Your support is crucial and helps us continue to bring you these incredible in-depth explorations of history's most compelling stories and machines. Thank you immensely for watching, and we'll see you in the next one.